Original background. There we go. All right. My background started actually in human biology and neuroscience. What really fascinated me was the things we don't know about our own bodies, but let alone the human brain. The fact that we only knew, and still to this day, don't know everything that the human brain is capable of, how it works, all these unanswered questions, etc. And so I wanted to help answer those. And I was really fascinated with neurodegenerative diseases, which really led me, first of all, to my first path in applied research and hands-on research. I love being in the lab. I love being able to work on really challenging problems with a great team. And from there, I started really getting into understanding.
I sent you a link, but that might be specific to my RSVP.
I'm going to go ahead and mute Alejandro. If everyone could just make sure that you're muted, that would be fantastic. But as I said, my focus really started at looking at different systems. So this would be water systems, food systems, air quality systems, and how that impacted human health. For me, my driving force, where I got my most energy, was making sure that I was working on things that I felt could make an impact. And so that's really where naturally started with human health. The more I started to look at things like climate change and all these different environmental systems, to me, these all seem to boil down to one common root or common denominator, which really was our energy systems. So if we could figure out how we could incentivize the use of renewables and really think about the different types of energy sources we were using, then we actually could impact human health. And started thinking more and more about where this actually could lead us and what the future holds. So in a bit of a 180, I originally thought I was going to go to medical school. And because I love school so much, I was like, I'm going to do an MD PhD. Yay, student loan. But after thinking more about this, I was like, well, maybe being a doctor isn't where I could have the most impact, or what excites me the most. Yes, we need doctors, of course. Yes, we need more research. But at the end of the day, what actually excites me and where does that impact come from? And the more I thought about it, I thought, well, okay, I like the research piece. Maybe if I was able to focus on research looking at this intersection of clean energy systems and technologies that could help incentivize that, maybe that's another way or a different path to still having that impact on overall human health. So for my master's degree, ended up, as I said, pulling a bit of a 180 and started focusing on microgrids. For those of you who don't know, microgrids could either be virtual or actual physical. So they're, as defined, smaller grids, usually with solar, sometimes geothermal, et cetera, different forms of renewable energy at a much smaller scale, sometimes at a household level, sometimes at a neighborhood level. And what really drew me to these is, okay, if we could actually have a more flexible grid. And so I actually ended up doing my master's degree out in Geneva, Switzerland. So got to also live abroad. It was great, really great cheese and wine and chocolate. So that was great. But also I got to see the different types of technologies that were being used. And so one of the things that stood out in my time in Geneva is they have this gigantic fountain or geyser coming out of the lake. And what they set up was this different type of hydro pump that ended up pumping all the cold water into the city to help with their cooling costs. And what interests me is, how do you begin to think about critical infrastructure differently? And so my master's thesis started to focus on, okay, well, critical infrastructure, urban areas, where are one of the epicenters of impact and economy, and that's airports. So my master's thesis looked at how can we look at airports and apply different IoT, different technologies to have more efficient grids and ideally help move towards microgrids. So I looked at Geneva, Switzerland. I looked at Los Angeles, so LAX, and then also the new airport that was being built in Abu Dhabi, and comparing and contrasting what were the different technologies being used, whether that was RFID tags for bags, electric vehicles on the actual tarmac, operating with equipment and cargo between the planes, or more broadly, how the airports were being connected to the grid and what role that played in these urban areas. The more I dove into microgrids, though, the more I realized that there was, I was trained classically in statistics, and so started getting into predictive analytics, which quickly finds itself into the world of machine learning. And I was like, oh, this is interesting. Now, mind you, this is back in 2015, 2016. And so for me, it was thinking about, okay, well, what's, what do I want to do next? Like PhD seems logical. Again, you could tell most of my upbringing was just like more school. Like that was just what was taught to me by my parents. That's all we knew. So I was like, okay, like, yeah, PhD seems logical. And let's look into more of this machine learning. If we're going to be having more electric assets on the grid, more electric vehicles, well, particularly in the US, that's going to cause a lot of issues. Like our grid system already is incredibly brittle. It's not very flexible. It's also, from a national security standpoint, incredibly important. So how can we use different technologies to have, virtual power plants, or, think about these different technologies as well? So that's what led me to Stanford. And so started a PhD at Stanford, and specifically worked at SLAC National Research Lab, not SLAC with a K, SLAC with a C. I get that asked a lot. So no, SLAC with a C is not doing anything related to renewable energy. You'd be surprised. So many people are like, wow, oh my gosh, SLAC is doing such great research. Yeah, no, different SLAC. So SLAC National Research Lab, I was part of the group called Grid Intelligence, Mobility, and Systems Group, GISMO, because everyone loves acronyms. And it was really, for the research I was doing there, focused on the intersection of AI, machine learning, and energy systems. And so I led a project called GRIP, Grid Resilience and Intelligence Platform. And what we really set out to do was, how do we anticipate, absorb, and recover from grid events, whether that's wildfires here on the West Coast, nor'easters on the East Coast, and everything in between? And can we use different types of technology like reinforcement learning, predictive analytics, to actually be able to mitigate some of these risks, or be able to intervene once a grid event has occurred? And it was fascinating. I got to meet with so many different utility companies, both in California and across the country, to understand what were their pain points. The number one pain point was it's a legacy industry. And so their use of these new types of technologies just wasn't prevalent, and for the most part demanded that everything be on-prem. Don't even get started. Actually, we partnered actually with Google X on this project. And one of the interesting things was how many utility companies refused to use cloud. That was just like a new thing for them. They were like, we don't know if we could do cloud. It's like, that is where the future is headed. Like and it's come a long way. Sure, it had its bugs early on, but it's pretty reliable now. So that was one of the, I think, big updates was, okay, where's the ground level for where these utility companies are starting? And increasingly found myself really excited about where AI and ML was headed. So now we're coming up to like 2017, 2018, big Google paper drops. And my background, again, I'm a trained scientist. I do research, but definitely was not coming from a traditional computer science background. So even though I took some courses at Stanford, started to teach myself, was very interested, I wanted to learn from the best. And so one of the key themes that hopefully should have bubbled up during my talk is learning by doing and learning from experience. So that means connecting with people. Yeah, there you go, Brian. Is connecting with people, asking good questions, and actually seeing how it works in the real world. That was my number one frustration with academia. As you could tell, I'm a bookworm, I'm a nerd, I love learning. But my biggest gripe with academia was we're publishing papers, and at the end of the day, not all of it actually gets deployed into the real world. And that's actually the most valuable data. How are people actually using it? You could try things out in theory all day long, But at the end of the day, how someone uses something, or, you know, how real world physics impacts something, there's no replacement for it. So anyways, like I said, I wanted to learn from the people who were the experts, who were the best at AI and machine learning at the time. So on what was Twitter at the time, now X, I started following folks at DeepMind and a little research lab in San Francisco called OpenAI. And it just so happened that one day in fall of 2018, I believe, they said, hey, you know, we're going to have a happy hour. Come meet our research scientists. Come meet us. We're nice people. Come hang out, have a drink. I was like, oh, that sounds awesome. Like, I want to meet these people. So went up to the city and it was awesome. At that point, they had 20, maybe 30 employees, mainly all research scientists, developers. And it was awesome. Met Jack Clark, Greg Brockman, Ilya, and there were a couple of key takeaways from that night. One, just how awesome they were. I think people at the end of the day make such a difference. And so willing to nerd out, again, even though I didn't come from that traditional background, and more importantly, they were interested in my background. They're like, wow, how are you thinking about energy? What should we be thinking about when it comes to data centers? That actually is going to have a huge impact on what we're trying to build. And it started to connect all of these different dots for me. The other key takeaway was, again, having spent most of my life in research and academia, here are these researchers saying, we're going to build artificial general intelligence that benefits all of humanity. And at that point, they still hadn't deployed anything. Some research, yes, but it wasn't even a cap profit yet. There was no product yet. The roadmap wasn't quite clear, but the destination was. And what stood out to me was the level of ambition that these people had. They were going to stop at nothing to make that possible. And I really had not experienced that anywhere else. Here are these awesome people who are going to figure it out, and they've got a really great mission driving them. And so I thought about that on the way back home, and I was like, wow, this is like a really incredible group there. And they also were like, and we're opening up a role that we need someone with an interdisciplinary background who actually can help us think through how we're going to maybe productize or commercialize some of our research, and how we're going to deploy it. How is this going to impact other industries? And being able to actually have that real world knowledge would be really valuable. So I got home, I had a few DMs in Twitter from folks I had met being like, you should join. And it was the same feeling I had in my gut that I had the day I decided to not pursue medical school. I can't really describe it. I'm sure you all have experienced it at some point in your life, but that feeling in your gut of, you don't really know what the future holds, but you just have to go with it. Something about it felt right. And I ended up dropping out of Stanford, leaving Slack, and joining OpenAI. And at that point, like I said, there were about 30 some employees joined them. I was definitely one of the oddballs, if you will, in terms of my background, but everyone was so welcoming. And the point, you know, the experience was we were building it from the ground up. I joined, and it was probably a few months, maybe even weeks after I joined, that I got paperwork saying, oh, and we're no longer a nonprofit, or we're going to be this thing called a cap profit. I was like, okay, interesting. Then a few, more months go by, maybe the following year, talking with others on the team. Okay, so we're going to have to think about, how we're going to productize this. It's like, okay, that's interesting. They're like, how about an API? All right, let's look into that. Will anyone use it? Does anyone know us? Mind you, this whole time, most of my family and friends thought I was crazy. They're like, you're working for this like no name, like, what is this? You work at AI? Like, what is this? Like, you could have had a PhD at Stanford. Why? And I was like, I don't know why, but these are really great people, and I enjoy what I'm doing, and I'm building something from scratch. So a few years progress and things start getting interesting. So we start first with GPT-2, and a lot of my role at this point, again, early stage startup, wore many different hats, but really what I started gravitating towards was applications. How do people actually take the technology, whether it's written about in an archive paper or behind an API, how are they going to use it in the real world? What problem are they trying to solve? So first we released GPT-2, again, mainly a lot of scientists, academics, but in terms of architecture, we felt like we were onto something. And so really what I'm most proud of, one of the things I worked on was I led the launch of GPT-3. And so that was definitely, we didn't know what was happening. Mind you, most people forget that was in the middle of the pandemic. So we were all home as well, which is also pretty crazy as I think back on it. And really, I mean, being up till 2 a.m., trying to finalize the final demos. We're going live at 6 a.m. Like nobody had any sleep. We're gonna press send. Is anyone even gonna care? And it ended up being, you know, what is now in the history books of a definitely wild ride. And so seeing, you know, developers trying things and capabilities we didn't even think of. And so after that moment, after launching GPT-3, a lot of my focus was building our first developer ecosystem. So obviously I'm talking to the right group here, and really creating a community for people who are trying to use our API, figuring out new capabilities, new use cases, whether they were devs, whether they were creatives, folks at enterprises or folks at organizations. And we learned a ton. Most of my days, I was having like 14-hour days of just back-to-back conversation, Zoom calls. Like that was insane, but awesome. I was talking to people literally all over the world at all the hours of the day. And one conversation in particular set me on another trajectory. It was a conversation with a group from NASA Ames. And I was like, wow, okay. So as you can tell from my background, I've been obsessed with aerospace since I was a kid. And I really felt this moment of, oh my gosh, NASA wants to use GPT-3. Oh my God, this is going to be like the best day ever. I can't wait. They're going to want to, I don't know, build a new spacecraft, have a new mission. There's so many things that's going to be so great. And so we get into this meeting. And so the first thing that they say is like, yeah, we're really excited about GPT-3. We have paperwork about this high that we're trying to get through. Can it help us, you know, do some data parsing, maybe some summarization, and really help us get through all this paperwork? And I was like, wait, what? Paperwork? Really? And they were like, yeah. Like, I was like, but don't you, I don't know, want to create something else? They were like, well, we can't really do anything else until we get through the paperwork. And that was such a key lesson for me, because it also opened my eyes to, that's where a lot of people were starting from. That was actually a lot of the use cases was, okay, I want to get through the work that I actually really don't enjoy doing, so I could spend time focusing on the things I do really like dreaming up about missions to Mars and new types of spacecraft and asteroid mining. But we can't get there until we get through the, you know, the admin work. And so then I started, you know, I left that conversation kind of perplexed, and I was like, huh, is it just NASA? Like maybe it's just that group. So I mean, that data point of one. So I started to think, well, I wonder what the rest of the space industry is like these days. What kind of technologies are they using? And then I started asking myself, oh my gosh, if what we're building here at OpenAI like is going to have all the impacts that we think it is, like where's the aerospace industry starting from? Similar to what I experienced when I was working on the GRIP project with all the utility companies. Where are they starting out at? And so I started doing a ton of research. SpaceX, Boeing, a number of other groups. What type of technology are they using? And I learned about LabVIEW, and I learned about also how inefficient it is to do research on the ISS, and also how expensive it is. More importantly, I was like, whoa, there is such a deep divide between like these groundbreaking technologies we're developing and, you know, these core industries, whether it's aerospace, whether it's medicine, energy, etc. And so as I led the launch for Codex, Copilot, and at this point I'd been at OpenAI for 3 years. And for anyone who's worked at a startup knows that it's like dog years. Each year is like 7 years. You learn so much. You're truly drinking from the fire hose. Awesome team. We were about 150 people now. I mean, things were really cranking. People were, you know, started to know who we were. People were using our technology. And I didn't think OpenAI was going to be, starting an aerospace division anytime soon. And I started asking myself, well, is the knowledge that I have, the experience that I have with where I know AI is headed, would that be most useful to help the aerospace industry and being able to actually share that knowledge and create value for what the aerospace industry wants to achieve? And so made the tough decision to leave, strike it out on my own. And the other thing is my time at OpenAI gave me the confidence to leave, because one of the number one questions I get asked is, why would you ever leave? And yes, the team was great, the pay was good, the food was awesome. Obviously, the impact was incredible. But at the end of the day, it's a whole nother ball game if you want to take those lessons learned and then apply it to another field. And that is something that I realized I was doing my whole life. Learn a domain, learn everything you can about it, and apply it to the next one, and unlock a different way of thinking, unlock different problem solving skills. And I realized, I'm good at that. Like, I actually like that seems to work. So took what I could and really took all those lessons learned and decided, all right, I'm going to try this startup thing. And so started my first company called Titan Space Technologies. And so our whole goal was, okay, you know what, where's a good starting point? And one thing that became very clear, like I said, was looking at the ISS and how research was done on the space station. And I was like, all right, well, could we build computer vision models for anomaly detection that would help astronauts have much more visibility to experiments running in parallel, instead of, okay, I'm going to work on this plant experiment from 1 to 2, and then from 2 to 3, I'm going to work on the meniscus experiment, et cetera, very siloed and fragmented. And so giving that visibility actually made experiment throughput, much more streamlined, much more efficient, and you got a lot more data, and being able to actually make much better use of that data for those experiments. And so we ended up running our computer vision models on the ISS, on their HPE Spaceborne 2 in less than 8 months from incorporation. And so had an incredible team who worked incredibly hard to make all that happen. The next step was, all right, how do we think about integrating our software with hardware? And so we partnered with Blue Origin to do a suborbital flight. We wanted to see, can we actually now take our computer vision models and adapt in near real time an experiment and actually make use of those just 3 minutes in microgravity? So we 3D printed a bunch of magnetic deltas that were on these launchers that would launch these magnets into the payload locker upon hitting microgravity, with the goal of forming a perfect ring of magnets within the 3 minutes. The idea was the GoPro cameras would detect and actually make recommendations based on the data coming in, the velocity with which the launcher should be firing, and make those adjustments. Unfortunately, we were on the NS-23 flight where the booster separated early from the capsule, so we did not reach microgravity as intended. But one of the things that we learned from that was how to make lemonade from lemons, because it turns out, even though we didn't get to microgravity, we still captured all of the data from that entire flight, from launch to booster separation and return back to ground, both audio data, visual data, and actually found it to be quite helpful for the folks as they were trying to forensically piece back together exactly what happened. And so the takeaway was, data is key. Collect everything you can and be able to actually use that to help tell the story, to understand what happened, and see if you could actually glean insights from that. So again, continue to learn a ton, and increasingly start thinking about, well, what's the future of hardware as we begin to deploy these increasingly multimodal models? And so that's a lot of what we started to think about. And so fast forward to this year, and thinking about, well, one, the AI world has changed a lot since ChatGPT, which was almost exactly a year ago, and really what that means for startups, what that means for developers, and how could I also take that knowledge and make that useful. And so Growth Warrior Capital is how I came to meet Brian, and was thrilled to join the team as a venture partner and a strategic advisor on AI earlier this year. And so a lot of my role is one, connecting with founders, and two, understanding how they're using AI, or for portfolio companies, different ways of thinking about deploying AI. And for those of you who tuned in yesterday to all the announcements, and if you haven't, I strongly suggest that you do. But my key takeaway and what I hope you take away from this talk is things are increasingly moving at light speed. And whether it's Google, whether it's OpenAI, Anthropic, Microsoft, whoever it is, we're in a really exciting time. And I think the key takeaway is you think about your own, whether it's a career in software development, maybe you're going to become a founder, or many other things in between. But the point is, these tools are incredibly powerful and accessible more than ever. Just with even being able to create your own GPT like yesterday, announcing and thinking about what the future of agents are going to be, and how you can begin to automate a lot of processes and things maybe you don't like doing. And you can actually have that time to think about some of these bigger, more ambitious projects. So really, and the title of the talk is Connected the Unconnected, because if you look on paper, I have a very non-traditional, non-linear background. And what I really like to share with folks is nobody has it figured out, and you're always going to be learning on the fly. The most important thing is, how do you take these lessons learned from each experience, each degree, each person you meet, and apply them, because that's really where the value add comes from. And so I want to encourage all of you to, one, be optimistic about the future. There's so many great things that are going to be built, that many of you are going to build, and that you don't need to have a linear path, and that actually sometimes the most exciting ones are the ones where you combine, mix and match and combine, much like Lego pieces. So with that, I'll stop and open it up for questions.
Awesome. Thank you so much.
Silent golf clap. Woo!
Yeah, we're taking care of the audio right now. Go ahead and repeat your question.
So the usage of okay, from that day, so the GPTs, do you think they could be implemented in a way that it could kind of read a bunch of files from an archive? Or it has to be kind of like developed in a way that it can read specific markdown files and text files?
Do you want to repeat?
Were you able to get the question, Ashley?
What I heard was
Oh, now it's muted.
okay. Can you hear me? Awesome. So what I heard was, per yesterday's announcement about GPTs, do I think that essentially you could build a GPT that either you would upload your own archive papers, or you would actually have it go and kind of like scour different archive papers? And there was something about in the next 6 months, but I didn't catch the last part. Brian, maybe if you could repeat, since you're closest to the mic.
Just speaking of this,
Yeah.
and I'll go through.
Ask her.
Oh, cool. Go ahead. Yeah, I know we can come to you now.
Oh, nice. Hello, this should be a bit better. Basically, I guess I will kind of go in more detail because this would be more self-explanatory. Research assistant for one of the UAV labs in Cal Poly Pomona. Right now, what you address, like issues of paperwork, is very relevant to me. So I was like, oh, so with kind of connecting everything, it's like for GPTs. Right now, we have a lot of documents, and a lot of new students who are joining us are struggling to capture a lot of the questions they have. So I was just curious if GPT could be used in a way that can make it easier for newer members to join our lab and like know everything they ever could ask, basically, from an archive that we give it.
Oh, yeah. Oh, that's a great use case. I mean, what I'm imagining is you could almost have like whatever your lab's name is, GPT. And so being able to upload, let's say you've got meeting notes or updates. I mean, so in terms of context, you're looking at least up to 300 pages of a traditional book. So if you've got about 300 pages of documents, you could put that all in one go. So I love that idea. And that makes me think about whether it's for new labs or new clubs, or even in companies onboarding people, like almost like what is your wiki or your archive, but being able to ask those questions. Usually you have to do a lot of like treasure hunting and figure out, okay, so this folder, that folder. I think that's an excellent idea. You could even start with just the ChatGPT interface for GPTs, and you can upload in those knowledge, and I don't know if you have access right now or not, but what Sam had showed, you could have you could upload those specific documents like right in there as well. So I think that's really cool.
Kind of furthermore with how to upload to the archive, do you think you'll be able to kind of interface with a like GitHub repo, for example, or even a OneDrive?
Ooh, so the short answer is yes. I think I'm obviously very bullish on a lot of these tools, and so I think, you know, what you're going to see is just a lot of integration. I think the conversation about yesterday on connections. So OpenAI making the connections with Microsoft and Google. So to access your Google Drive, etc. If you caught Satya and what he said when he was talking was to make the connection with GitHub. So that sounds like that is probably on their roadmap, and to have basically the ultimate goal is interoperability. Your GPT should be able to go where you go. So any files you're using, platforms you're using, basically should be able to operate with what you're using. And I guess full disclosure, and since this is being recorded, I am not a current employee of OpenAI, and anything I say is purely speculative. And do not quote me on any of this.
Anything makes it easier for me to like start searching, because we'll end up like trying to figure out how to use GPT in this way. It's just that like it'll make it a lot easier to not explain what a LiDAR is or trace study or CODR and all this stuff again. So this GPT will make a lot easier time for a lot of the like veterinized techniques.
It totally, I mean, it makes it much easier to get to the point. I mean, I don't know about all of you, like I can't keep up with all the research coming out. I'm just like my list of archive papers is crazy. And so being able to summarize really quickly of the like, why should I care? Like why, or why is this even like, is this actually groundbreaking research, or is this just like an incremental update? It helps me get through a lot of the research and helps me actually prioritize which ones do I actually want to maybe over the weekend go and read in full. Because at the end of the day, no one has all the time, and B, you actually don't need to read like the full paper. And so being able to, you know, summarize, prioritize, and get through that very, you know, as quickly as possible is incredibly useful.
Awesome. We have a question on Zoom, so we're gonna go ahead for that, and then we'll be able to take one or two more in-person questions.
Cool. So are there any industries you think weren't affected by ChatGPT? That is an excellent question. So there are two ways you can read this question. And so there's the version where affected by ChatGPT in the sense that you're a startup and maybe you're building like some kind of wrapper or etc. Around the API. And then there's the version of the question of, you know, industries utilizing the tool. So the short answer to the second question is every industry stands to benefit from leveraging ChatGPT, the API, etc. I mean, per the example we just talked about, getting through paperwork, information, knowledge sharing, organization, there is just so much that companies are just trying to get through. And it's not just technical debt, it's what I call knowledge debt. How much knowledge has been generated that are inside companies, inside labs, etc., that people just forget about. And so that, like, these agents are going to be so helpful. For the first part of that question on industries and kind of companies being affected, I think it's going to be an interesting basically broadly, like the future of computer science and software development as we know it, I think is going to be very interesting. I think with the prevalence of no code tools, I think people are going to be more creative. And I mean that in creative problem solving, what you can build. I think any industry is not impacted. Anything that is highly regulated. So I'm talking about like the FAA and like airlines. healthcare, so like, drug discovery, et cetera, like actual implementation in like clinical trial, not just like, oh, we're gonna simulate something. Those are gonna be the ones that it's just harder and harder to utilize. I mean, even aerospace, it's one thing to have a software tool that you could try and test things, with. It's a whole nother thing when you need to 3D print a rocket nozzle and like have it on the hot fire test stand and like see if it doesn't melt. So again, it goes back to testing things in the real world. And I think those are just going to take the industries that have a lot more of the atoms based applications are going to take a little bit longer to integrate some of this technology just because of regulation or verification, quality control, et cetera.
Awesome. Those are some honestly really great responses. We're gonna go ahead and do one more in-person question and then we're gonna call it. Really quickly for the folks in the room, we have pizza. If you want more pizza, get some pizza, please. We gotta get rid of it.
Send it.
Hello. Can you hear me right?
Yes.
Right. Hi, I was just wondering, I know when you said you started the aerospace company, that you actually left OpenAI before you started. When you started, how did you integrate ChatGPT? Was it like you started as an API? Or started using the API?
Yeah, so actually, interesting enough, for our computer vision models, maybe some of you guys know RoboFlow. So actually, we were using RoboFlow for a while, and that was really great because a lot of what OpenAI was doing, to be honest, actually hasn't been in computer vision. We were really focused on leveraging different types of descriptions for like the different, experiments and things like that. Or being able to generate new types of experiments. So that was something that we were looking into is there a way that you can generate a new type of like product test, for example. So what is some type of product that would benefit from microgravity research? So yeah, those are kind of some of the different ways we were looking into it.
Oh, follow-up question to that. Does the company still use the API or did you guys like create your own instead of the model?
So I didn't catch the last part of that, but I heard basically, does it still use the API? Or-
Yeah.
Got it. So yeah, no, actually we wound down the company. So that's why I started with Growth Warrior, et cetera. Yeah. So it's not running on the API or anything right now. I'm working on something new and we'll, share that more in the future, but definitely still at the intersection of AI and aerospace. But yeah, so we weren't directly using that anytime recently.
Thank you. I'm gonna hand this back to Brian now.
Alrighty, we have some time. Any more questions?
There isn't time, we have class in 3 minutes.
That's funny, yeah. Thank you so much, Ashley. We're gonna have to cut it right here, right now, because we are moseying on. We really appreciate it. So much. Super inspiring. Thank you. Y'all want to say thank you? Give a round real quick.
Thanks, everyone.
Thank you.
Yeah.
Bye, folks. Hey guys, pizza, remember, it's pizza. Thank you, pizza.